Lesson 4 presents the application continuity and disaster recovery related use cases of VMware NSX. This lesson covers the following topics: VMware NSX, cross vCenter networking, how VMware NSX can provide application continuity, how VMware NSX can be used with a disaster recovery solution, how VMware NSX can be used during data center consolidation, how VMware NSX is used with long-distance vMotion. Application continuity is about delivering the data center anywhere. Some data centers might be using a private cloud, while other data centers might be using a public cloud. So if a data center becomes unavailable, we can still access applications using a different data center. VMware NSX provides a way to easily extend networking and security to up to 8 instances of vCenter either within or across data centers. In conjunction with vSphere 6, customers can easily use vSphere vMotion to move a virtual machine across long distances, and VMware NSX will ensure that the network is consistent across the sites and that the firewall rules are consistent. This essentially maintains the same view across sites. VMware NSX cross vCenter networking can help build active data centers. Today, customers are using VMware NSX with Site Recovery Manager to provide disaster recovery solutions. VMware NSX can extend the network across data centers and even to the cloud to enable seamless networking and security. Application continuity involves the following aspects: disaster recovery, metro pooling, hybrid cloud networking. The business value is reduced recovery time objective, or RTO. One of the challenges of multi-site infrastructure is that it is too siloed. So you have a physical location with its compute, storage, and networking, along with your applications. Now you have a second site with its compute, storage, networking, and applications, and a third site with its recourses as well. This is how many of the metro and geo deployments look today. Each site has its dedicated physical resources with application boundaries constrained within the site. Not only are application boundaries constrained, but even the cross-site connectivity is difficult to design and build. Very expensive networking technologies with dedicated hardware investments are put in place. Management and operations are siloed as well, which requires security policies to be restricted to a single site. If the application is redeployed or expanded to another site for high availability or expansion, the policies are rewritten. In short, you have sites, but availability is siloed. Operations and management are separate admin domains for each site, and security policies are local to the site and do not move with the applications. Thus, the policies have to be replicated rather than moving with the application. Application deployments are site-restricted either due to connectivity constraints or operations management policies. A large capital expenditure is needed just to provide basic connectivity between the sites. Let us look at each of the following components of disaster recovery and how they are recovered. Compute, storage, network. Click each component to learn more. To add to networking and security challenges, retain the application topology and policies between the data centers. Also ensure application IP space is preserved and applications can connect to other components to support partial failover of some components or planned migration, stretched subnet. The technologies available to ensure IP address preservation and connectivity act as a virtual private LAN service. Cisco's Overlay Transport Virtualization, or L2 over L3. These technologies are complex and require the knowledge of a networking expert. Not to mention that these are typically built on top of WAN edge routers, which creates cost and complexity. This is out of the realm of a disaster recovery or virtualization administrator. One of the questions most commonly asked by customers with multiple data centers in the same geographical or metro location is how they can create a unified pool of capacity without worrying about infrastructure silo when they deploy the applications. Basically, IT should be able to deploy applications without creating specific tweaks to access resources in other locations. vSphere 6 cross vCenter vMotion and technologies such as VMware vSphere Metro Storage Cluster, or VMSC, already address resource silo issues in storage and compute. Networking must evolve to provide the same, a virtualized logical network that spans across multiple sites. That's where VMware NSX comes in. VMware NSX helps IT or cloud admins create these unified pools where applications can be deployed in any location, yet be able to seamlessly connect to the resources located across the sites. This has been the most prevalent use case for VMware NSX in a multi-site deployment. Let us look at an example from a customer deployment with VMware NSX and VMware Virtual SAN. The first step is to unify the data store across the metro with technology such as VMSC and Virtual SAN Metro. No more siloed data. Use vMotion to distribute the virtual machine workload based on capacity or even adjust the capacity. Create VMware NSX Network Hypervisor layer from the vSwitches. No change is required in the physical infrastructure. Create your logical networks and run the application, decoupled from the underlying infrastructure and physical location. Create the virtual machines and assign them to the correct logical switches, security groups, tags, and so on. Now what you have are the applications that are highly available across the sites. Security policies apply across multiple sites, so that security policies follow the virtual machine. This is another example of multi-site deployment with distances beyond metro deployments. Due to distance limitations, a stretched storage is not an option in such deployments. Instead of single vCenter over a stretched storage, there are two vCenter deployments and storage is not stretched. With cross vCenter vMotion and long distance vMotion supporting 150 milliseconds RTT, customers with these deployments can create a pool of capacity across a longer distance and provide logical connectivity with VMware NSX. VMware NSX Multi-vCenter enables cross vCenter networking and security so that customers can deploy applications across two sites and two instances of vCenter up to 150 milliseconds latency. Also, you can perform local egress from each site as desired. This is far superior than existing data center interconnect or DCI approaches that require dedicated circuits from service providers or expensive equipment and fiber. With a one-to-one relationship between vCenter Server and VMware NSX 6.1 and earlier versions, The local vCenter inventory is the boundary for logical networks. Deploying additional L2, L3, and firewall constructs in other sites are disjointed, as they are configured under a separate vCenter to VMware NSX relationship. There are scenarios where a single vCenter can span multiple sites, but VMware NSX 6.1 and earlier versions were still constrained by a single vCenter limit. VMware NSX allows an administrator to link multiple vCenter VMware NSX deployments together and manage them from a single VMware NSX manager that is designated as primary. This allows an administrator to manage the deployments from a single interface. VMware NSX can overcome the single vCenter boundary to provide L2, L3, and firewall services at the hypervisor without the single vCenter limitation. Enterprises deploy multiple vCenters for a variety of reasons, and VMware NSX will now allow logical networks to span multiple vCenter instances. Universal logical switches allow L2 networks to span multiple sites without having to purchase any additional physical network devices. When you create a logical switch and select a universal transport zone, you create a universal logical switch. This switch is available on all clusters in the universal transport zone. The universal transport zone can include clusters in any vCenter in the cross vCenter VMware NSX environment. This provides the ability to place the workloads based on the resources available in any vCenter, without having to worry about the networks available. This feature can also be used for migrations from one vCenter to another seamlessly. There are valid use cases for deploying multiple vCenter servers, such as self-service cloud provisioning and VDI. So eliminating the one-to-one relationship between vCenter and VMware NSX allows for better network scale with reduced administrative overhead. Distributed firewall in a cross vCenter VMware NSX environment allows centralized management of rules that apply to all vCenter servers in your environment. vSphere 6 supports cross vCenter vMotion, which enables you to move virtual machines from one vCenter server to another and seamlessly extend your SDDC security. As your data center needs to scale out, the existing vCenter servers may not scale to the same level. This may require you to move a set of applications to newer hosts that are managed by a different vCenter server. Alternatively, you may need to move applications from staging servers to production servers in an environment where staging servers are managed by one vCenter server and production servers are managed by a different vCenter server. Distributed firewall supports these cross vCenter vMotion scenarios by replicating firewall policies that you define for the primary NSX manager on up to 7 instances of secondary NSX manager. Once you designate an instance of NSX manager as the primary manager, you can create universal rules within a universal section. These rules are replicated on all instances of secondary NSX manager in your environment. Rules in other sections remain local to the appropriate instance of NSX manager. VMware NSX enables virtual machine mobility boundaries that align with vSphere 6 vMotion enhancements on top of existing infrastructure with no additional hardware requirements. VMware NSX does not require spanning of L2 on the physical network to enable cross vCenter vMotion. Cross vCenter vMotion supports up to 150 milliseconds RTT, so you can migrate a virtual machine with vSphere vMotion from vCenter A to vCenter B. When the vMotion is complete, the virtual machine runs in vCenter B. VMware NSX with Cross vCenter capability introduces new options for multi-site solutions. With VMware NSX across sites, we can configure active data centers with L2 spanned universal logical switches, east-west routing across sites with universal DLR, firewall rules across site with universal distributed firewall, ability to handle north-south traffic with failover and/or local egress at each site. Disaster recovery with Site Recovery Manager is another great use case for multi-site VMware NSX. VMware NSX provides a synchronization of VMware NSX objects across sites. You can then create 2 Site Recovery Manager sites to allow per virtual machine level disaster recovery with these objects. In the event of a disaster, Site Recovery Manager can recover the workload and connect them to logical objects that have been synced with no need for adjusting IP addresses or security postures. Site Recovery Manager does not automatically protect the VMware NSX components, such as the controller cluster. Cross vCenter VMware NSX deployments have many benefits. They offer a comprehensive solution for L2, L3, and firewalling without any need for specific hardware configurations. You can choose any hardware vendor. These solutions not only build on top of existing solutions, but also integrate deeply with other VMware products that fulfill the SDDC vision. There is no rip and replace requirement to achieve these benefits. The traditional disaster recovery solution is tied tightly to physical infrastructure, physical routers, switches, firewalls, and load balancers. The security domains of the protected and recovery sites are completely separate. As networking changes, be it new adds or deletes, updates are made to IP address, L2 extension changes, subnets, and so on at the protected site. No corresponding automated synchronization happens at the recovery site. Thus, you may have to perform an L2 extension to preserve the changes, create and maintain special scripts, manage the tools, and perform manual disaster recovery setup and recovery steps across different infrastructure layers and physical and virtual vendors. From a process point, it requires coordination across various teams within your company, good bookkeeping, and periodic validation, so you are always ready to address a disaster recovery scenario as quickly as you can. The slide depicts how disaster recovery is done prior to using VMware NSX. At the primary site, a snapshot of the virtual machine is taken. Then the virtual machine with its storage is replicated to the disaster recovery site. When a disaster occurs, the virtual machine is recovered at the disaster recovery site. The IP address of the virtual machine is changed to match the network at the disaster recovery site. VMware NSX offers a solution that enables customers to address the networking challenges just described. VMware NSX is the network virtualization platform for SDDC. VMware NSX provides the basic foundation to virtualize networking components in the form of logical switches, distributed logical router, distributed logical firewall, logical load balancer, and logical NSX Edge gateways. VMware NSX has been integrated with Site Recovery Manager 6.1 to enable automated replication of networking entities between protected and recovery sites. For additional information on VMware NSX, click the Resources tab. The slide depicts how disaster recovery works with VMware NSX. At the primary site, a snapshot of the virtual machine is taken. The virtual machine with its storage is replicated to the disaster recovery site. The network snapshot and security is replicated. At the disaster recovery site, the VMware NSX network and security policies already exist. When a disaster occurs, the virtual machine is recovered. There is no need to change its IP address. This can decrease the RTO by 80%. Lastly, another multi-site use case where VMware NSX is leveraged in data centers is consolidation and migration. A common facility consolidation, capacity expansion, or mergers and acquisitions are used to bring acquired assets into your data center. This used to be cold migration, but with long-distance vMotion and cross vCenter vMotion, you can now perform hot migration of workloads. The customer's goals here are generally to preserve the IP address of the virtual machine and avoid a new dedicated hardware-based DCI just for migration and consolidation. VMware NSX provides a secure, automated, and on-demand solution for such deployments. The deployment of an L2 VPN service allows extension of L2 connectivity between two data center locations. The diagram highlights the creation of an L2 VPN tunnel between a pair of NSX Edge devices deployed in separate data center sites. VMware NSX in a hybrid cloud is another important use case where VMware NSX plays a key role in connectivity and unified network or security policy between on-premise workloads and hybrid cloud. Technologies such as VMware NSX L2 VPN and Site-to-Site VPN with IPsec enable seamless connectivity between on-premise and hybrid cloud resources. You can connect your private cloud to the hybrid cloud with either L2 or L3. The hybrid cloud provides a single policy model, and VMware NSX provides a secure L2 or L3 connectivity and unified policy between your private cloud and hybrid cloud. There are three major categories for VMware NSX use cases: security, IT automation, and application continuity. Some VMware NSX projects for security are microsegmentation, DMZ Anywhere, Horizon View, and VMware AirWatch. Some VMware NSX projects for IT automation integrate VMware NSX with vRealize Automation, vCloud Director, and VMware Integrated OpenStack. Some VMware NSX projects for application continuity are Cross vCenter NSX, Cross vCenter vMotion, Disaster Recovery, and Data Center Migration.